I never know what to post on this channel, so let's just talk about binary. Alright, we'll start off with the fundamentals of computers and work our way up. Alright, so essentially binary is a two-number numeric system, also called base 2. We work in a base 10 system, which means your numbers go 0 through 9, and a binary system goes through 0 through 1. The reason why computers use a binary system is because the central processing unit is made up of silicone sheets that are like microscopically laser engraved with resistors. These resistors only have two states and they're either on or off. Electrical signals will enter your computer through like waveforms, and it'll take these waveforms and interpret them as either a 1 or a 0 or an on and off state of these resistors. It'll then compute the resistor state into anything from websites to images to UIs to anything. It does millions of computations a minute. Sorry, I have my whiteboard set up, so we're going to do this kind of in a janky format, but check it out. So binary, you have 0, 1. 0 equals off, 1 will equal on. That's pretty simple, but let's talk about counting in binary, which is something pretty simple, but it sounds super complicated. Okay, I went ahead and put out the basic numeric scale for binary. Pretty much, you're always going to multiply by 2. So you start with 1 times 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, and so on and so forth. It goes on forever. Okay, so to convert 1586 to binary is simple. So 1586. We'll find the biggest, largest multiple of 2 to apply to it. So this would be it. 1, we're turning that on. So when we turn that on, it's going to minus 1024 from this. And when you minus that, you're going to get 562. Okay, 562, boom, 512. So we'll take 562 minus 512, which will give you 50, okay? Then from there, 50, 32 goes into it, which is 1, 32, that'll give us 18, 16, 18, minus 16, remainder 2, boom, 2. Okay, then all you do is fill in the blank. So 0, 0, 0, over here, 0, 0, 0, and then that's it. So now your finished number, if you look across it, will be 11000, 110010, which is a binary explanation for the number 1586. Seems pretty complicated, but it's really not. It's super simple. But that's how you convert decimal to binary. Now let's do the reverse. We'll take 110011 and convert it into decimal. This is pretty simple. You'll just plug in your binary number over the multiples of 2, and then once you have it laid out like that, it's as simple as adding it together. First, you'll take your 64, add 32, then you'll add your 2 and 1, which gives you 99. And then there you go. It's that simple. So in this problem, 110011 equals 99. Straightforward, and it's way easier to convert from binary to decimal, I can tell you that. Now, this is a very rudimentary explanation of binary. I can go more in depth if anybody wants it, or if you want me to explain other complex computer topics in simple terms, feel free, leave a comment or DM me and I'll make a video of it. But for right now, yeah, that's binary. It's the life and everything of your central processing unit, how your computer shows you everything from social media to websites to music to everything. It all comes down to ones and zeros. So thanks for watching, and I hope you learned something.